welcome back to AGT STEM. Today we're going to be watching a video about bismuth. So, without further ado, let's hop to it.
Okay, I've got a piece of crystalline bismuth. So you can actually take sort of pellets of bismuth metal and actually heat it up. I've seen photos of people doing this on their home sort of cookers, their ovens and things. But you can make them in the lab. So you get crystals of bismuth out which look like this, which is actually really, really pretty. And there are websites where people have made lots of these crystals and they're selling them for collectors and things, which is quite nice.
Bismuth is interesting because it is the heaviest element that is not radioactive. You can imagine the nucleus, the centre of the atom, rather like a blob of water. And if you imagine a drop of water, as it gets bigger and bigger, it becomes unstable and will easily split into two. And it just happens that bismuth is the largest size that's not radioactive.
The interesting thing about bismuth actually is that it's long been regarded as being, bismuth 209 has long been regarded as being the heaviest non-radioactive element. And technically, actually, that's not true. It was actually found, I think, about 5 years ago now. It was actually proven to be an alpha emitter. So it's actually a radioactive element, emits alpha particles.
So here is a very old sample of bismuth. This is a bismuth rod, and you can see it's packed up really quite nicely. But we can open this and we can go in and have a look to see what it is, you know. So here, if we pull it out carefully.
But actually, it's kind of a little bit sort of pedantic, I suppose, because the half-life of this bismuth 209, they found is actually about, is it 1.9 times 10 to the power 19 years, its half-life. So that's the time it takes for, say, a kilo of bismuth, for 500 grams of it to decompose to its daughter element, which I think is thallium-205, if I'm right. And so that half-life is actually longer than the current age of the universe. So for all intents and purposes, it's still quite stable. I think they actually call it metastable.
It is used particularly in an alloy called Wood's metal, which is a very low melting alloy, will even melt in boiling water. And there were endless practical jokes where you could buy Wood's metal spoons and you give it to somebody to stir their tea, and it melted in their tea and they looked surprised.
See, bismuth. Yeah. Really old sample from Johnson Matthey. Now let's see if we can find out what the purity is. So it's at 99.9%. Really quite nice sample of bismuth rod.
Bismuth, surprisingly, is not very poisonous compared to the fact that lead is very poisonous, and so there are some suggestions that we should be exploring more the chemistry of bismuth as a catalyst, because if it works well, then it could be used in chemical processes with much less danger than some of these other materials.
So if we can push it out from this old paper packaging, and you can see it's packaged really quite nicely. Here you can see the bismuth metal itself. Bismuth is used in catalysis to attenuate selective reactions, so perhaps we might use bismuth with a platinum group metal like palladium or platinum even, to make chemistry go a little bit more selectively. It's a really beautiful element though, really nice. So we'll pop that back in there nice and safe.
Why have you got that? Where'd that come from?
I bought it because it's so pretty. I bought it from a shop. I can't remember actually which shop now, but I collect these sorts of things, the very, very pretty looking sort of metallic things and crystals. And as you can see, it's really nice and iridescent, so it's got a tarnished oxide layer. It shines like sort of, you know, all the colours of the rainbow, which is really, really pretty in my opinion.
Lovely.
Thank you so much for watching, and we'll see you next time. Stay smart. Bye!